We're going to give a presentation tonight on the state of the Eastham ponds. We have a couple of speakers.
Microphone.
It's on. The microphone is on. We're live broadcasting on the TV channel, and we will have this available on the website along with the pond report and the pond fact sheets after the event this evening. So with that, I'm going to introduce our speakers and who we have present today. We have Liz Moran online. Liz is a planning and restoration specialist at Anchor QEA. She is an environmental scientist with a long career in lake and watershed management. Liz was part of the GHD team for Eastham's wastewater management planning project and led preparation of the 2011 Eastham Ponds Action Plan. She continues to work with the town of Eastham during design and implementation of the allume treatments for Herring Pond and Great Pond. In 2024, Liz updated the State of the Eastham Ponds report and the associated fact sheets. Liz and her colleague at Anchor QEA supported the Cape Cod Commission team with the Freshwater Initiative. Sitting next to Jane Crowley, who you all know as the former Director of Health and Environment. And then we have Heather McElroy. Heather McElroy is the Natural Resources Manager and Planner at the Cape Cod Commission. She works to develop appropriate tools and policies to help address the region's natural resource and land use challenges. And her work has contributed to many regional projects focused on improving communication, knowledge, and action on natural resource and climate change issues on Cape Cod. And then we're supposed to have Julie Hambrook Berkman from APCC. However, she hasn't shown up yet, but if she does, we'll go ahead and introduce her when she arrives. She was going to talk on cyanobacteria. To my left, we have Susan Baker, the health agent, and Sam Poyant, our administrative assistant. So with that, Liz, go ahead.
Okay, great. Thank you so much. So go ahead and click to the next slide. Okay, so I'm just going to cover the first two blocks on here. I'm going to give a brief introduction to what kettle pond ecosystems are and what's important and how we can manage them, and then delve into the state of the Eastham ponds. So next slide. So we'll start with the review of limnology. And, limnology, for those of you who haven't heard me talk before, limnology is the science of freshwater ecosystems. It's kind of parallel to oceanography is the science of saltwater systems. So I'm going to give just a few slides about the physics and chemistry of pond behavior. This will be really helpful in understanding the pond ecosystem. So as we look at the Eastham ponds and figure out what we're measuring and why, you can understand how the physical and chemical environment really affects habitat and all the ways that people can use the ponds and the ecosystem. But let's start way back at the beginning, the glacial age. The kettle ponds of Cape Cod are remnants of the glacial ice retreat. And we see that as the kettle ponds, as the ice sheet retreated, chunks of ice broke up and then were buried in the sand and outwash that was came in as the glacier was receding, and their meltwater formed the peninsula, Cape Cod, where we know and love. And this picture here, the aerial photo at the top of your screen shows an important feature of the kettle ponds, which will become, you'll understand later why this is being highlighted. There's no streams and rivers flowing in and out of most of these ponds. So the lower graphic kind of shows their creation, and eventually the buried ice chunks melted, the groundwater level rose, and the depressions left behind were filled with groundwater, basically. But over the centuries, they have provided great habitat, and there's a real interesting assemblage of species that live in the kettle ponds. So next slide. So kettle ponds are called windows into the aquifer, and that's one way to express this interconnection. So there's a surface water, groundwater connection. Ultimately, the kettle ponds discharge into coastal estuaries, and the conditions of the ponds, the quality and habitat and usability or suitability of the ponds for various purposes is really affected by local and regional conditions. So we're going to talk a lot about that. And then, of course, Heather is going to share a lot of her knowledge across the Cape. So the next slide talks about ecosystem services. And this is a theme that we'll come back to throughout the presentation, particularly when we start talking about the Eastham ponds. People interact with and benefit from the Cape Cod kettle ponds in many ways, as I've listed on this slide. And the health of the ponds is also assessed on various scales. So we use metrics to evaluate pond quality in many ways that reflect these human uses and expectations and values. So can I swim in my pond? Is it as beautiful now as it was when I was a kid, coming to visit my grandparents? Are the fish safe to eat? There's a lot of these questions that reflect our human values and ways that we want to be able to utilize the ponds. Okay, next. Oh, I always use this slide. Heather has seen this slide multiple times. This is a quote from like one of the foundational texts in limnology. And you can read it, but the theme is that change is inevitable. What we see as permanent features of the landscape are actually ephemeral. I mean, not in our human lifespan, not in the scale of centuries, but eventually. And this is just to remind us that change is inevitable. And on a decadal scale, actually, this is an aerial image, what you're seeing here, which is from the Cape Cod Pond Atlas. And each update of the Pond Atlas, it turns out they have fewer ponds in their inventory. And that's because on the decadal scale even, the inventory changes. Wetland vegetation encroaches on ponds, the groundwater level changes, goes up and down, and that affects kind of what gets actually mapped as ponds. So, okay, next slide. Yeah, still back to kind of basics of limnology here. Let me scroll down one second. Thank you. So I'm going to introduce a concept here that is going to be important when we start talking about, again, the Eastham ponds, particularly the ones that we have done some kind of interventions on. So going to talk about phosphorus, dissolved oxygen, and sediment chemistry, thermal stratification, lots of kind of concepts in physics, chemistry, and biology that ultimately affect these ponds. So what you're seeing here is a cross section of a pond. And this pond is actually deep enough so that over the course of a year, it develops thermal layering, right? So the sun adds heat to the surface of the pond. Warmer water is less dense, so ultimately it floats, and then it develops these fairly stable thermal layers, depending on how deep it is, how sheltered the pond is. And so you have this upper layer where there's light penetration and you get growth of photosynthetic organisms, phytoplankton, which are the tiny algae and cyanobacteria that live in the water, aquatic plants. And then as you go deeper into the pond, you get these cooler layers. So as the organic material is produced by photosynthesis, dies and decays, it sinks to the bottom, and you have this box that's called sediment respiration. That's the microorganisms that are breaking down that organic material. And they do that in the presence of oxygen, typically. But as that oxygen gets used up, the decay processes use different chemical pathways, and that changes the chemistry of the sediment layer itself. The impact of that and why we're going over this is as that sediment layer, the upper sediment layer, becomes devoid of oxygen, the chemical bonds that hold phosphorus in the sediment change. And so phosphorus then gets released back into the pond water. Okay, so nutrient cycling, you'll see that that's important. So, ponds don't have streams flowing in and streams flowing out. So as you're accumulating phosphorus, it tends to stay over time. If it stays locked in the sediment, it's not going to affect the level of production of the pond. Once it starts to cycle back into the upper waters, it has the potential to do that. And you'll see that this is happening in many of the ponds on the Cape, including some in Eastham. Okay, so next slide. And what's happening on the landscape around the ponds affects how nutrients reach the ponds, right? So there's two basic nutrients that we worry about or think about or track as limnologists thinking about the science of fresh water. One is nitrogen and the other is phosphorus. Now you'll note on this graphic that the nitrogen lines tend to be the same size and larger. This is to depict that nitrogen is pretty soluble and moves through the coarse sandy soils of the Cape pretty easily and reaches the pond without too much loss, except for some microbiological loss. Phosphorus, on the other hand, is much more apt to be bound and held up in the sediment particles themselves. So phosphorus from, you can have runoff from impervious surfaces, paved areas, roadways, roofs. You could have fertilizers from homes and gardens and agricultural activities. You can also have nutrients from septic system discharges, that reach the groundwater. And ultimately, as we know, the groundwater is moving in and out of the pond. So what happens on the landscape affects the nutrient flux into the ponds. Okay, next slide. And then the ponds themselves affect how they respond to that nutrient sources. And ponds react differently. I mean, it's kind of intuitive maybe that size matters. Larger ponds have greater dilution. So if you have a nutrient load of X grams, it's going to result in a different concentration, right? Depending on the volume. But there are other factors that affect how each pond responds to this external nutrient load, and they're listed here. So some of it are, physical factors, others are biological factors, what's the nature of the food web and the fish communities, and then management, fish stocking, interventions to try to interrupt the nutrient cycle or increase flushing, lots of, kind of management interventions that people can do. But basically, each pond is going to respond differently. Okay, next slide. All right, and one more thing, we're talking about phosphorus a lot. This is another cross section. Remember, we have the upper warmer waters where light penetrates, and then we have the deeper waters. We also have this kind of littoral zone, is called, where light can penetrate to the bottom and you don't get aquatic plants and things. So each phosphorus each pond has a different type of phosphorus cycle. It's affected by its depth, the thermal layering, productivity. And then, as we said, dissolved oxygen really affects the chemistry at the sediment water interface, but it also really affects the habitat, right? So cold water fish, for example, are less tolerant of low dissolved oxygen concentration. So you get different kind of fish communities developing in these ponds as well. Okay, next slide. And I've already said phosphorus probably 10 times. Phosphorus is a key indicator of pond health. It's something that has been routinely monitored for decades. It's something that is comparable across many programs in states. And there's kind of a scale of, phosphorus going from low to high. And then, this is kind of a scale of blue clear water to green, murky water on this. But you can see there's different attributes. Some of it's for fisheries and recreation. Some of it is for algal blooms. Anoxia, that means lack of oxygen in the deep water. So that is, of course, more of a factor in productive ponds where you have a lot of the decomposition going on from the organic material. So that is something that limnologists have tried to figure out for years, put scales on this. There's some general guidelines, but of course, because of the unique nature of each ecosystem, there's the other factors, right? The physical and biological factors as well. So next slide. Oh, and we are going to talk about cyanobacteria and harmful algal blooms. Hopefully, Julie will be able to, share a lot of her knowledge on this. But probably everybody's read about or heard about or talked about cyanobacteria or harmful algal blooms. Cyanobacteria are photosynthetic aquatic bacteria. They're a very old organism. They're super diverse, thousands of species across habitats and a huge range of habitats from hot springs to polar areas. They have some unique adaptations. They're buoyant. They can move up and down in the water column, and that's a strategy for being able to access, nutrient-rich depths or to get up into the sunlit layer to, photosynthesize and grow. They are a concern. Some species, not all, can produce toxins, neurotoxins and hepatotoxins that can harm people and pets and, are really a concern for water supply systems and also recreational contact. They also are uniquely able to fix or, utilize nitrogen that's in the atmosphere as a nutrient source. So this makes them very different from like green algae or diatoms or aquatic plants that are growing in your ponds. Those species are dependent on nitrogen that is in the water, right? Or comes in from the atmosphere, but, in rain or something. But the cyanobacteria, that's one of their many unique adaptations that makes them so successful across so many environments. This figure is just kind of a little schematic of why do we get cyanobacterial blooms? Well, you need nutrients. Warm water really affects their rate of growth, and quiescent conditions as well. So calmer waters, warmer waters, and nutrient-rich waters are the ones that seem to be most susceptible to cyanobacterial blooms. Okay, next. And let's see, drivers of change. I know Heather's going to talk about this as well. So as the climate warms, here's a graph on here of the annual mean air temperature. This is from the Chatham Airport, but you see these trends everywhere. The bar charts on the bottom, though, compare air temperature change during two different periods, 1970 to 2000, compared with the 2001 to 2023. And the point of putting this in here, so you see that, yes, the daily averages are increasing, but it's not uniform across the seasons. The fall is really where we're seeing a lot of warmer temperatures. And for those of you who live on the Cape, I bet that you can, you all have stories to tell about this. And this, of course, affects the ponds. It affects their average temperature, but also their seasonal period of mixing. So if we have longer, warmer fall period, that stratification stays in place longer. The water doesn't cool enough for the fall winds to mix it, to overcome the thermal gradient to mix the waters. So the outcome is those bottom waters are isolated for longer. And because that also increases the risk of developing anoxia, the low oxygen conditions, and then the release of phosphorus that are held in the pond sediments. Okay, next. The other driver of change is something that we've also all experienced, development pressure. So this is a graph from the Cape Cod Commission of population within Barnstable County, so the Cape, from 1970, and it's more than doubled from 1970 to 2020. So along with the increasing population comes more wastewater, more impervious surfaces, and also a risk of kind of what we call emerging contaminants, plastics, wastes, things that can also have unimpacted or undesired impacts on water quality. Okay, next. So what does this bode for the future? Well, we have warmer waters, certainly. Warming waters and affect, biochemical reaction rates, right? Things grow faster, things grow larger, and then the habitat impacts on the aquatic community, the temperature, and also the dissolved oxygen cycle. We are seeing an expanding range for invasive species, right? As species tend to be migrating north into areas where they were not able to survive previously. And then, of course, the increased risk of cyanobacteria and HABs from the warming waters and the enrichment. But it's not all bad news. I mean, there are things that can be done. There are things that are being done that will be helpful. But it's good to understand kind of what these external drivers are so that we can figure out what can local communities do. What can be done at the local scale to protect the resources that we treasure so much. So now I'll transition into the state of the ponds. Okay, next slide shows kind of the elements of the wastewater management planning project. And as Hillary mentioned, I have been fortunate to be involved from fairly early. Started with, it was Stearns and Wheeler at that point, but started working with GHG on their wastewater management planning, and my role was to look particularly at the ponds and the Eastham Action Ponds. Some of the recommendations from that pond, the alum treatments in Herring Pond and Great Pond, followed on subsequently to that. And then there's just been a whole lot of local work, Phragmites treatments and hydroraking, aeration. You can see these, and I bet many of you are very familiar with it. The town website has a really good kind of documentation of all the projects that have been done. So in 2023 was the Targeted Watershed Management Plan, and right now, apparently, Hillary and Jane have shared that, the design of the wastewater collection and treatment system is underway. So that's great progress. And of course, there's a lot of ongoing things, in addition to the long-term monitoring that's going on. There's a lot of stormwater management projects as well. So again, capture and infiltrate water, so it's not, carrying undesirable substances into the ponds.
And you know what, Liz, this slide is really interesting because we've been giving the wastewater presentation with town meeting coming up for the collection and treatment system. And we briefly touch upon various planning activities and projects that have occurred, but this slide really shows it in good detail. So I'm glad we put this one in.
Oh, good. Well, feel free to use it in any of your upcoming presentations. Okay, next. So let's focus in now on our ponds in Eastham, and you can maybe you can put in the chat or something which pond you're most kind of familiar with or connected to. But Eastham has a lot of ponds, and we also have a really robust data set thanks to committed volunteers and the collaboration with the SMAST program and all of that support, the Center for Coastal Studies, the commission, of course. We'll hear about the Freshwater Initiative, and you'll see the three ponds noted in red here are included in the regional monitoring, the Super 50, right? Or I forget what we end up calling it, Heather, but something like that. And that, of course, the Freshwater Initiative is also in collaboration with APCC. So, there's just a lot of great work being done, and including, and I'm sure Heather will talk about this too, the Cape Cod Commission successfully went back and captured all of those years of PALS data and put it into screened it, put it into a database and made that accessible. So people can really drill down and look at their pond and see what's changing. So that's a just tremendous amount of work. Okay, so yeah, you can see that lots of the Eastham ponds have had very consistent monitoring program. The PALS program targeted a late summer sample, thinking that, this is kind of the time of the year when phosphorus and chlorophyll will be at their highest. The nutrient concentration and the growth of phytoplankton would be at its annual peak. And then through the PC, oh gosh, Center for Coastal Studies, that's better, yeah. They're also taking samples in the spring before the ponds undergo their thermal stratification. So this is a really good data set because it shows, okay, this is the kind of the supply of nutrients that are available within the pond before it divides up into layers. And it's kind of, if you track that over years, it's another really good index of change over time and just how the ponds are aging and being affected by what's happening in their landscape. And then the regional monitoring program is very robust, has multiple samples throughout the spring and into the fall. So pre and post stratification periods. Okay, next slide. All right, so let's drill down here. These are the ponds with kind of robust data sets here. Trophic state, I mentioned, I think that limnologists have tried to put ponds and lakes into various classifications depending on their productivity. And so eutrophic is ones that are very productive, mesotrophic are some kind of in the middle, and then oligotrophic, for which, we don't have any oligotrophic ponds in Eastham. In fact, I doubt if there are any. Well, no, maybe Cliff Pond. Well, anyway, they are not typical of kettle ponds. And then this is the total phosphorus content. Chlorophyll, kind of the chlorophyll is, of course, the photosynthetic pigment that's present in the algae and cyanobacteria that are floating in the water, the plankton. Secchi depth is a measure of water clarity. So higher number means clearer water, because what you do is measure it from the surface and see how deep in the pond. You can still see the instrument, the Secchi disc. But this final column here on status is probably something that is of real interest. We have mostly stable ponds. Minister Pond improving. There's been a lot of interventions and work done on Minister. Little Depot is the only one that we see declining, getting increasingly more enriched in phosphorus and higher concentrations of plankton as time goes by. And then there's also asterisks on 3 of the ponds with this, the footnote. Those are ponds that are on the state's list of impaired water bodies, the 303D list, it's called. That's just named after a section of the Clean Water Act. But what's in parentheses is, why did they get placed on that list? So Mall's Pond, because of HABs, cyanobacterial blooms. Great Pond, phosphorus and chlorophyll A, which I still think might be worth challenging a little bit on the state DEP about that, but that's Depot is listed for obstructed fish passage. So anyway, these are the trends. The good news is the stability of the ponds. Okay, next. So I want to talk about 2 ponds now, Herring Pond and Grape Pond, for which we actually did an intervention. And this intervention was an alum treatment program. So what happened was, in the fall, Solitude Lake Management, which it had a different name at that point, which Jane probably remembers.
ACT,
What was it?
Aquatic Control Technology.
Yeah, that sounds right. So that was the contractor that did an alum treatment program, which injected a mixture of aluminum sulfate and sodium aluminate into the deep water of the pond to reach the sediment surface. The purpose of that was to increase the binding capacity of that sediment for phosphorus. So even as dissolved oxygen got used up in the pond water, that additional aluminum complexes provided more binding sites, and they would keep that phosphorus bound in the sediments. So we see here that this was actually very effective in Herring Pond. This is the plot of chlorophyll. So you see that post-treatment, the summer average chlorophyll really declined. The other positive note that we kind of drew from looking at the 2024 pond update, the calculations of the dosage rate were for a 10-year binding capacity. And we're at that, and we're still seeing really excellent results. So that's a good thing. It also speaks to kind of the effectiveness of some of the local measures that have been in place since then. So, efforts to educate the community on wastewater and garden management and, kind of best practices for lake living are probably really extending the life of this alum treatment. And the second graph is the Secudis. So you see much clearer waters also post-alum, which is, of course, because there's less chlorophyll. So that's good. Okay, so that is the herring pond story. And the next slide shows the same metrics for alum, the alum treatment of Great Pond, which was done the subsequent year, so 2013. And so we see a real decline there as well in terms of chlorophyll. Not so much difference in Secudis transparency, but the two treatment systems were designed for different reasons. Great Pond was considered a kind of protective measure. So much less alum was added. A lower kind of percentage of the lake bottom was treated, and that the dosage was smaller. So the idea was, let's just give more additional binding capacity. Where in herring pond, pre-alum treatment, the water quality was pretty impaired. So one was kind of a rehabilitation. That was the herring pond. The second was kind of a proactive preventative, and that was Great Pond. But again, we're seeing sustained improvement. So that is really encouraging. Okay, next slide. So, we're getting to the end of my talk, so other people can have a chance to talk. So the action plan, which is going to be on your website, has some specific recommendations. And they're in categories that are kind of span kind of spatial, things you can do in the pond, things you can do along the shoreline, things that you can do in the direct drainage or the watershed of the pond. And then a lot of regional partnerships and collaboration that has been just so helpful. So in pond, aeration for minister and schoolhouse has been effective. They shoreline surveillance and control of Phragmites and such. For the nutrient inactivation, the alum treatment, just keep an eye on it, keep monitoring, and eventually you may want to plan for a repeat alum treatment when you start to see a decline in the effectiveness, but it's still holding really well. Invasive species, that is an ongoing challenge, and the best actions that we can recommend at this point are just early detection, rapid response, community engagement, make sure people have access to the tools to identify and report what they're seeing, so that the best time to try to control it is when they're first there before they spread all over. Hydro raking to manage vegetation and access, recreational access improvement. HAB surveillance and outreach. Again, public information is really important. How to live safely with HABs. And of course, the health departments are playing a major role with that. And then, of course, the integrated monitoring programs are just really providing invaluable information and data. So along the shorelines, you see a list of recommendations. The watershed, this feeds into your, the watershed management. You are moving ahead, we're really taking the steps that need to be done. Stormwater management, we're seeing a lot of those actions. Again, capture and infiltrate. Keep talking to people and keep collaborating. So that's basically the recommendations, nothing earth shattering. We're not seeing a lot of brand new technology yet. I mean, I think there's a lot in the works, but we don't have a lot of documented success stories to share. But again, because of the partnerships that are going on and the communication hub, through the Cape Cod Commission, there'll be a library, access for municipalities to learn more about the alternatives, the effectiveness, and case studies as they develop. So kind of centralizing that information sharing, I think it's also going to be really key as new technologies develop. Okay, one more slide. I think, and these are my takeaway slides. This is what, after you've listened to me talk now for 41 minutes, apparently, these are the key takeaway points. The uniqueness of the pond, that they're changing. Change is inevitable, but there are things that people can do to affect that rate of change. Phosphorus is really key, but it's not the only factor affecting the rate of change. The warming waters have just these cascading effects throughout the pond ecosystems. So physical, chemical, biological. The real need to continue and focus on monitoring. And then, local actions count. I mean, there are effective things that can be done, and Eastham is really keeping on top of it. So congratulations to you all. And that is the end of my section.
Thank you, Liz. And now we'll move on to Heather.
Great. Thank you. And thanks, Hillary, for inviting me. And it's a pleasure to be here to talk about this work that we've been doing. Really to talk alongside Liz and Julie, who've been great collaborators in so much of this work. So yeah, I'm going to give sort of a zoom out big picture, regional picture on the work that the Cape Cod Commission has done to look at ponds across the region over the last year. Yeah.
Any questions or from the whole? I just have a question on the last.
Yeah, that's okay. You can go ahead and ask your question. I was going to hold them till the end just so we could get through the presentations, but if it's pressing and you want your answer now, we can certainly take it. Go ahead.
Well, I was just wondering, under what conditions do you make the determination to treat Great Pond and Herring Pond without?
Liz, did you hear the question?
Yeah, the question was, under what conditions did we make the decision?
Mm-hmm.
Okay.
We're going to make the next decision on the next.
Oh, so when do we decide that it's time?
Yes.
I think it's just tracking the annual phosphorus concentration in the pond is probably the best metric. So when we start to see that
Yes,
that
I'm sorry.
is
Where they want.
Sorry.
And you're.
Sir, could we have you come to the microphone to ask the question just so that the folks online can hear? I'm sorry. I forget that there are other people with us.
Sorry, I don't mean to foul up the system here. Am I being understood? Hello?
Yes.
yeah.
Just a quick one, on your slide for like Herring Pond and Great Pond, the x-axis is imperceptible. Is there a way to enhance that?
Yes.
Okay. Yeah. Can you click back to that?
Instead of clicking back to it, we can make the slides larger and we'll have it online. So you could see it from your computer screen, which make it easier.
Oh, okay. I just didn't understand the digits there. I took a picture of it and expanded it with my phone, but it doesn't come out.
The computer, you can get it nice and big and we can see, which one are you looking for in particular?
Oh, Herring Pond and Great Pond. And it has the chlorophyll, I think, but you don't have a phosphorus reading for those ponds.
it's either in micrograms per, like, you have to click back. It's either in micrograms per liter or micromoles. Um, But yeah, all that, it's all in the report, so,
Okay,
yeah.
These ones?
yeah,
There you
yeah,
go.
okay. All right, yeah, no, that works. I understand.
I guess
see.
I can add, since I was involved in these projects when they were discussed and chosen for intervention, that we did a complete assessment, including sediment analysis, which we did test the phosphorus. So we had clear visual impairment where people who historically had enjoyed the use of those ponds explained that the water quality had degraded to a point that it was really getting to a point where they could no longer enjoy the pond due to the excessive algal growth. So we did a complete assessment, and Herring Pond was at that time the most impaired. We had a committee which discussed the options. We rated the impairment of the ponds categorically, and then that was the one that was present, the most impaired. So that was the one that was chosen, Herring Pond. Great Pond, again, a very widely used recreational, you know, resource for our town, was showing again the impairment. So again, just as Liz had said, one was really needed at a much higher dosage in terms of getting that algal growth under control, and whereas Great Pond was lesser, but it was all based on assessment and scientific data that was driven from the ponds themselves.
And you're continuing that with Herring Pond, so you have a whole set of database that,
We continue to monitor the ponds, as Liz mentioned, both in the spring and the fall. So in terms of looking at the alum success story, we actually plan this year to do a more detailed analysis and do not just spring and fall, but do it also in conjunction with some of our saltwater sampling, so that we have a really in-depth look year round at what's happening, because it does change. Ponds are very tricky. They change from year to year. So we really are trying to keep a handle on what's happening.
The alum treatment for Herring Pond was successful.
Yes, very.
Uh,
Both were.
But the pond's back to where it was, in case anybody's interested.
That's why we continue to monitor, because we really need not just anecdotal information, which is very important. We need that scientific data.
And your data is on the website?
The data is not, well, it's collectively not on the website. We do have it available. If you wanted to see year to year, we could certainly share that with you, but it's to a certain extent more information than people really need. We do share it with APCC and the Cape Cod Commission, and they are putting together regional assessments. It's a lot of information, so it becomes very tricky to evaluate.
You have a phosphorus rating specifically for those ponds?
We test saltwater and freshwater for different parameters. So we do phosphorus testing in both freshwater and saltwater.
And that data is available.
Yes.
Be interesting to see what it is for Herring Pond and Great Pond. Okay, go ahead. Sorry.
No, that's quite all right. I could understand after, Liz's presentation, wanting to get into some of the specifics about the East Ham ponds. I am going to sort of take a step back. So the Cape Cod Commission received funding a couple of years ago now to embark on what we call the Freshwater Initiative. And what I'm going to cover is some of the work, the outputs from those 2 years of different tasks, and some of the tools and products that we developed as well. So if you could go to the next slide. So yeah, the way this presentation is set up, it is sort of referencing our Cape Cod freshwater strategy, which has been out for public comment. We've been sorting through comments and are actually hoping to publish the final version next week, if all goes well. So, but I'm going to just touch on some of the work that we've done, talk a little bit about how we defined the problem related to ponds, which you've heard a lot about from Liz, sort of the context within which we're working, the planning context, the different elements of the strategy, and some of the tools. So if you can go on to the next. So Cape community has loved and been concerned about its ponds for a long time. Cape Cod Commission was involved in a wastewater planning effort a couple of years back, which is really focused on marine water quality. During that process, huge engagement across the Cape, but we also heard from pond people, what about the ponds? So that's what the freshwater initiative was really about. And this effort recognizes that ponds are really fragile and needed a more intensive look. Next. So these are some of the elements of the initiative. I'm not going to cover all of these things. We have a very comprehensive website where a lot of all of these resources are available in the outputs. But suffice to say, we spent some time collecting and organizing data, engaging stakeholders, and developing tools and strategies. So we'll sort of talk about some of that as we go along. Next. So I'm guessing since you're here, you're either very engaged or curious about ponds, and that they're really a key component of the Cape's identity. And we heard through this process that people, felt strongly about protecting ponds and wanted to find out how they could do more and how they could be engaged. And further, that they really felt this was ponds are an integral part of our Cape way of life and economy. Next. So there are 890 ponds approximately that are freshwater ponds. I think Liz touched on the fact that this number has sort of gone down over the years. And it fluctuates to some extent with water levels and other things. But our definition of a freshwater pond and our GIS analysis of that determined that there were 890 ponds across the Cape. 166 of those are over 10 acres in size, which have implications for access. They should provide for public access, and also how they're managed. Some really lots of interesting facts about ponds. Of course, we're aware of the cranberry industry that was a part of the Cape for so long. There are 107 ponds that are adjacent to cranberry bogs. Some ponds are stocked with fish. A lot have protected open space around their borders, and a lot are actually significantly impacted by impervious surfaces. So a few factoids there, but you can explore more of that information in our pond atlas, which is available online. Next. So one of the consultants we engaged early on in this work was the Eastern Research Group, and we wanted them specifically to look at some of the economic impacts associated with ponds. They conducted several different analyses, sort of characterizing the economic contributions that the ponds make to our economy. And some of the key takeaways is that we know there are a high percentage of both residents and visitors who take advantage of ponds, recreating or otherwise enjoying them. And those actions have sort of a ripple effect through the rest of the economy. And then, yeah, you can go to the next slide, actually. That's all right. These are just sort of snapshots from the freshwater strategy. So if you go online, you can look at it and look at this information in detail, or you can look at the entire Eastern Research Group report. But some of the other takeaways are that, not a surprise, ponds with good water quality have a valuable impact on the Cape economy, and we can attribute significant jobs and business revenue to ponds directly. We know that people prefer ponds with clean water and beaches. And importantly, respondents to one of the surveys we put out, supported action to improve ponds and pond water quality. So some of those may be more intuitive, but one of the benefits of having time and resources to conduct an analysis is to confirm things that we suspect. And in fact, I found it fascinating that the support and the connections with the importance of pond health were as high as they were. Next. So I think Liz really got into this, and Jane has touched on it as well. Freshwater challenges are really complex. We anticipated that certain kinds of human activities were going to have an effect on water quality. But through this work, we've have a more nuanced understanding of that, and also an understanding that we don't understand everything we would like to know. So next, some of the there we go. Thank you. So the threats to pond health are interrelated. Liz spent some time providing a great detailed overview of the impacts of excess nutrients, other pollutants, those contaminants of emerging concern, things like pharmaceuticals or healthcare products that end up in our groundwater via our septic systems, are all, or other pollutants that wash off the surface of the land with stormwater and into ponds. They're all having effects, contributing to algal blooms, which can have effects on pond wildlife as well as human health. Erosion that is unchecked going into ponds contributes to that problem. Liz also touched on the problems associated with invasive and nuisance species. They can change pond ecology, and everything sort of can spiral out of control if invasives become dominant in a pond. And then climate change, we know, is changing precipitation patterns, changing temperature. Liz put up some graphs that help illustrate that. It exacerbates these other challenges. Next. So one of the other issues that came up was in understanding impacts on ponds. The data that had been collected, and there was a ton of data that's been collected for many decades now, was kind of sporadic. Lot of dedicated volunteers and other nonprofit entities collecting water quality over many decades through the PALS program, Pond and Lake Stewards program. But the ponds that were where that data was collected might change from year to year, might not be consistent data. So this was identified as an issue and part of the argument for making a concerted effort to do more focused monitoring on specific ponds. Next. And I'll talk more about that in a minute, but first we have just you know, put this into the regional planning context, this freshwater strategy is sort of the latest in the Cape Cod Commission's regional plans. We start with the regional policy plan, and from that sort of guiding document that sets out goals and objectives for the region, we pursue different sort of sub-plans underneath that umbrella. These plans are really cross-referential, acknowledging the interconnections between different land use activities and impacts that we have here. So if you go to the next slide. So here we have at the top of the slide, I mentioned the regional policy plan. The water resource goal and objectives is geared toward maintaining a sustainable supply of high quality untreated drinking water and protect, preserve, and restore the ecological integrity of fresh and marine surface waters. And then we have a number of objectives that fall under that. These other plans that are shown on the screen, including the 2021 Cape Cod Pond and Lake Atlas, which we updated from a 2003 version, the 208 plan, which gets at wastewater, the Climate Action Plan, which is about how the region responds to the changing climate, as well as the transportation plan, the housing plan, and the economic development strategy. All of these plans make reference to the importance of freshwater ponds to the region, to our economy, to our way of life. So all of this work has supported this in-depth look at ponds. All right, so next. So I think I mentioned at the beginning that it was the county commissioners who made available funding to spend 2 years collecting information, doing a lot of research, engaging consultants and stakeholders to better understand ponds and identify some potential solutions. Next. So stakeholder engagement was, I think, really great. We don't always have the ability to engage as many stakeholders as we would like. We started with municipal staff, interviewing them and understanding what their challenges are. We had a meeting with Jane in the next room over when she was still the health agent here. And from there, we went on to a variety of other kinds of engagement. We have, together with APCC, engaged pond groups into what we call the Pond Network. That's sort of a quarterly meeting of pond groups that where sometimes we'll have a speaker present, but really it's an opportunity for the pond groups to connect, share stories or challenges, and get more information. We also engaged a number of technical advisory groups to help us review some of the information that we were collecting and help us design how that information was presented back to the community, as well as the survey and the various analyses that the Eastern Research Group did. Next. So I think I've touched on a lot of this, a lot of work, research, the economic analysis. We did a lot of research on strategies for improving ponds. I have a couple of slides on that. We conducted a legal and jurisdictional analysis to understand some of the permitting challenges and other sort of management issues related to ownership and jurisdiction. We developed a freshwater pond buffer guidance document and a pond prioritization framework, which I think gets to one of the questions. How do you know which pond is next? Part of that is monitoring, but if you've got a lot of ponds that you want to do something to, how do you pick which one to do? And so this prioritization framework is meant to help communities. And Eastham has a prioritization framework, but not all communities do, sort of sort through moving forward with the next pond with given limited resources. Yes, next, thanks. So, so one of the analyses that we did was using our GIS, our Geographic Information Service, to characterize the land use activities around the buffers to ponds that could be contributing to water quality changes, trying to have a better sense. Is there something specific that is contributing to these the changing problems? I think we all went into that as just assuming that septic systems were the main contributor. They certainly are a contributor, but it's not that simple. So yeah, it's we also know that fertilizer from landscaped areas, maintained lawns, that is a big contributor, as is stormwater runoff. Anyway, that there's an analysis there that you can delve into in a little bit more detail in the Pond Atlas viewer. So there's been a lot of data collected, as I noted, a lot of historic data, but part of what we were able to do with the Freshwater Initiative is expand that data collection and collect all of that data, both the historic and the new data, into one place. So next. So Liz mentioned a bit about the ponds here in Eastham that are part of this regional pond monitoring program. We tried to identify at least 3 ponds in each community that would become part of this large, bigger picture regional pond monitoring program. So there are 50 ponds. APCC is the contractor working with volunteers to collect this information, this water samples, March through November of each year. It's really an amazing effort, and Julie might touch on that later, but we're now in the 3rd year. We've just started the 3rd year of collecting this information, and it's all being filtered into our database, which I'll touch on in a minute. But selecting those ponds was a very deliberative process, and I just wanted to make that point. We wanted to make sure that there were ponds across the Cape in each community. They had a variety of physical characteristics. We also wanted some variety in water quality, a few best quality water quality ponds, but also some ponds that were in poorer condition, public uses, etc. Next. So we've collected all of this information into a central database that the Cape Cod Commission maintains, and then part of the Freshwater Initiative enabled us to spend some time developing a water quality portal specifically for this freshwater quality data. And I think this could also get to your question, sir, about phosphorus. That's one of the measures that is presented in the water quality data portal. Anyone can go and access this information. And part of what we did was develop some graphs and tools that provide some analysis of the information that's provided, where that analysis is meaningful. I think that's an important thing. In some cases, there is no information on a pond, or the information is so limited as to, it doesn't make sense to try to show a trend because there is none yet. But that's a resource that encourage you to take a look at. Here's sort of a next one, please. Zoom in on the town of Eastham, and I, highlighted Minister Pond, and there's some initial data that gets pulled up there. If you visit the portal, you can then look at the data in the data view with more information. Next. One of the other ways that we're trying to collect more data, since sending people out to collect samples and then having those samples analyzed is an intensive effort, is through using remote sensing or satellites. So we've had actually 2 efforts where we've engaged, one with NOAA, National Oceanic Atmospheric Administration, and another with University of Rhode Island and University of Minnesota to pair satellite data with water quality information, a lot of it which has been collected by APCC, to better understand how ponds are changing. And that's a work in progress, but we're really excited about the potential there. Next. So strategies, we heard from stakeholders that they wanted to understand different ways to address pond water quality challenges. Next. We started just as Cape Cod Commission staff doing a ton of research. There's actually a really amazing guide. And I'm going to forget the name of it. For pond and lake management in Massachusetts, something like that. And it's just recently been updated, but we had the primary author of that guide serve on one of our technical advisory groups and help us sort of sort through strategies that could meaningfully address the threats that we've identified, such as excess nutrients, pollutants, et cetera. And we've organized it based on organized this information into a spreadsheet based on how that strategy is best used. Does it actually happen in the pond, like an alum treatment, or is it some action that happens around the pond shore, or is it more broadly in the watershed, which it could include things like zoning changes or other regulatory changes. Next, please. We output a lot of those, the strategies that sort of rose to the top as viable here on the Cape into fact sheets. And there's a lot of information on each fact sheet. That invite you to check that out. That's also available on the Commission website. Another really great tool, this is maybe not a dramatic slide, but we put together a viewer called the Pond Restoration Projects Viewer. And it's something that is a living resource we hope to build on. What it has is probably can't read it here, but on the right, you click on a pond and there's information about the intervention that happened at, in this case, Mystic Lake in Barnstable, sort of what was done, what were some of the effects, and some basic lessons learned. And I think the idea was to also include, sort of a contact, so it enables communities that are thinking about a strategy to, if you want to sort this by vegetation management, for example, it shows all of those interventions across the Cape where that happened, and then you can get a better sense of how that might apply for your project. All right, next. So one of the other products that we were able to develop with the help of a consultant was freshwater pond buffer guidance. This actually was a direct result from stakeholder feedback during the process. This was not something we had initially identified as something we would do, but we had a little extra money. And we were able to develop this tool, which is I have to say, a really gorgeous resource. A landscape architecture firm put it together. Next. It has, you know, some basic sort of education about pond ecology, so people understand what happens within the buffer area and the importance of maintaining a healthy vegetated buffer. It has, next slide, a ton of information about the benefits of native plantings and the negative impacts of invasive species, lots of great photos. Next, the I think it has 11 sort of conceptual plans for the kinds of plantings that might happen on different kinds of sites. So lots of ideas, not anything that you can plug and play, but a lot of information that is transferable to a different site. Next, this is just one of the pages with pictures of, in this case, woody shrubs, but there are lots of pictures of the plants. And then the next slide shows the chart of the plant list, one page of the plant list. This is an amazing resource, not just for people who might consider native restoration of native plantings in their pond buffer area, but really for native vegetation planting anywhere on the Cape. And you know, this line of circles in different colors is actually a quick visual on the bloom color, and it tells you when that bloom happens, the benefits to wildlife, etc. It's great. So next, I guess that's just the end. You can find that at our website. Actually, we do have a few printed. We printed them, and I brought one. I left it in the car. I meant to bring it in. I'll sneak out when Julie's talking. But yeah, if people want a printed copy, I'll leave this printed copy with you. Yeah. Yeah. Okay, so I'm nearly at the end here. Just briefly, the strategy includes several recommendations that sort of rose to the top. Next here, I think there are a few recommendations here related to funding, you know, finding more money, a way to bring more money to the Cape for pond restoration projects. Also more funding to continue the regional pond monitoring program. We actually likely have a solution for that. And providing technical assistance for accessing state and federal grant funds. I won't go through all of these, but suffice to say that there are actions that various entities can take moving forward, including, I haven't really touched on, I think one of the things we heard from stakeholders was, especially pond associations and pond groups, is the importance of education and communication. And so there are two recommendations about improving communication around ponds, you know, so just some basic information so that there isn't misunderstanding. So maybe I'll leave that there for now. And then next, so recognizing that there are rules for all of us on the Cape, you know, just from the individual who lives near a pond or doesn't live near a pond in changing their behavior, to landowners and NGOs, municipalities, and the regional government, all to take a role in doing what we can to improve pond health. There are some strategies or actions that the Cape Cod Commission has committed to moving forward, communicating the strategy, such as I'm doing here today, letting people know of it, about the resources that are available, identifying opportunities to expand and support monitoring, maintaining and expanding access to data so that water quality data portal and the maintenance of the data that goes into it. That's something we commit to continuing. supporting towns in writing grants to access grant funds, and developing model wetlands bylaws and orders of conditions, which was another key interest that came out of stakeholder process. So with that, I will stop. Yeah, a little longer than,
Thank you, Heather.
yeah.
All right, I'm going to go ahead and introduce Julie while Susan pulls up the slide deck. So Julie Hambrook Berkman is the Pond and Cyanobacteria Program Manager for the Association to Preserve Cape Cod. Her responsibilities include management, training, budgets, staffing, reporting, and program development. Julie works with citizens and organizations who care about Cape Cod's 890 ponds to obtain water quality data to help inform our efforts to preserve and improve pond water quality. Prior to working with APCC, she worked with the USGS National Water Quality Assessment Program as an aquatic ecologist from 1992 to 2008. Her work in aquatic biology began in 1978 to 1982 when she was hired as a Botanica Marina, marine botanist, with the I'm going to in Venezuela for their first environmental impact study of a power plant on a coral reef seagrass bed. During her PhD and after graduation, she monitored streams throughout North American Arctic, recording the distribution of freshwater algae. Julie has a PhD in biological sciences from the University of Rhode Island and a bachelor's degree in botany and a master's degree in education from the University of New Hampshire. Go ahead, Julie.
Okay, thank you. Thank you, Hillary. I gave you a pin drive. So,
Okay, yep, we're
yeah.
working on getting that up.
Sorry, I was just a little bit late. I got you. You can click through the first couple. These were just tying on with the talk Heather had given. But because she mentioned native plants, the Association to Preserve Cape Cod has been having native plant sales for the last number of years, and they've now developed a program with the growers of native plants. But for any of you who are interested, the plant sale is next week, and the way it works is you go online, you look at the 30 different native plants, of which we have thousands of plants at APCC right now. You sign up for what you want, and then you are given a time slot, and then you can go pick them up. But that's next week. So this is a good time to get native plants. These aren't big trees. It's just little plants. So there's so many things. I want to thank Hillary for inviting me. I'm just a tag on here because you had two big talks, and I'm going to try and go through things quickly. But it was through the commission and the Freshwater Initiative that I am working with ponds on Cape Cod. I'd come down here, and I wasn't even looking for a job, and I met Kristen Anders at, she was giving a pond, Love Your Pond talk, and at the end, I'd heard that cyanobacteria were the problem. I am an algae person, and that means I study these little things, and that's what I was doing today. I was talking to first graders in Falmouth, 200. 15 at a time, and I introduced them to all these different algae with little videos of the moving. It was precious. The little things you can't see. So you could click. This was one thing, Hillary. Yeah. So there's the little things. And if you've heard about cyanobacteria at all, the names that are on there are names you might have heard, like microcystis and delicospermum, that you don't want to have to say or repeat. We can go by DS. And the one down in the bottom, it took me 2 years to say it. I still don't know. Warwichinia, that's one way you can say it, but that shows up. And that's what we do every day. The cyano season is on. And we're looking under the microscope every day at the samples that are coming in. We do 130 ponds and 150 locations every 2 weeks. And we do that because 6 different towns have volunteers that collect the samples, and the rest are collected by us or the staff at APCC, or mainly the interns that we hire. So 5 college interns got hired, and it's impressive in our times when science isn't so funded that we had 95 applications for those 5 positions and 3 of the ones we hired are college graduates that can't find work elsewhere because funding has been cut. Just throwing that out there. Meanwhile, you can go on to the next slide. You've seen algae now. This is my favorite talk slide because most people just don't get it about these cyanoblooms. So the beginning one is showing that on a given day, you have algae in the pond, you have some cyanobacteria. Let's just say there's 100,000. What cyanobacteria do is the ones that we're mostly concerned about have gas vesicles. They have little things called aerotopes that we look at. So they float up to the surface. Why? To get more light. And after they're in the light for a while, they can, I say make the bread, but they're making photosynthesis. They're getting heavier because they're taking in the carbon dioxide and they're making carbon products. They get heavier, so they go back down. What's down below? All those nutrients that, we're trying to keep down on the bottom because we don't want them to get it, but they know how to go down. And then the next day they go back up again. So what's happening in the second slide is they've gone up. Now they're at the surface in the morning to get the light. That's why we sample in the morning. What happens when they get on the surface in the morning? Well, the wind blows. Not most days, there's some kind of wind on the water. So what direction is these algae going to show up? They show up on the shore where the wind blew them. Then they're concentrated down at the bottom. That's when it gets bad because you've concentrated them. So that's where you don't want the children or the dogs or anyone to be contacting them. And then the other part of the story is that the microcystis has the toxins inside the cell. And it doesn't really release them. It'll release them in the gut of the animal if a dog was to eat it, but it doesn't release them until they're degrading. So the rules are that you should, 2 weeks after you have the big bloom, you can go back in. You need to clear it because what happens is you don't see it. Oh, it's gone away. Well, it's gone away, but it's degrading. When it's degrading, it's releasing the toxins into the water. So, how would anyone know that? If I'm not telling you that, how would you ever know that? But that's microcystis. Some of the other ones don't work that way. They have the toxin and they're releasing it into the water. So you have to know the taxa, and that's why we put down what the dominant species is. Next slide. So this was what Hillary wanted me to share too. We've been doing this at APCC. This cyanobacteria program started in 2017. What we are about is trying to protect the public. Cyanobacteria is not regulated in any way, nationally or at the state level. There's no real rules. They came up with recommendations, right? Because they knew there was enough toxic. They are comfortable with making recommendations for microcystis because they have studied it enough and it has consistent behavior. However, the other ones, like the Delicospermum, which is more common on Cape Cod, has a worse toxin called anatoxin, which is a nerve toxin which binds with oxygen so the animals could suffocate. And that's probably where some of these deaths came from. But if you don't have enough to suffocate, it disperses and nobody even knows it happened. It's not in your blood system. So anatoxin is terribly difficult to work with in a research setting. You don't know in the bloom, maybe it's high at the beginning. It's very sensitive to light. The numbers could be high, they could be low. And so that's why we have on our website the acceptable, because we didn't find much, yellow, potential for concern. You're never going to know how much toxin's there. If you measure it one day, it may not be that high the next day. If you miss it. So it's just the fact that it's there. And those are just showing the scums. And in here, based on our years of, and you can find this on the East Ham
Yep, we have it.
website. It's called a photo guide. And it just says what we consider to be a major, that's on our website. That's on APCC's website. But there's also a pond guide to looking at what these cyano scums look like. Terrible word scum, but it's also not very nice stuff. So next. So I mentioned toxins. There are lots of different kinds of toxins. And the first one up there is hepatotoxin, which is the liver toxin. If any of you know your Latin, you'd know hepato was liver, but not everybody knows that. So anyway, the liver toxin, that's microcystis. So microcystis that's what you're going to get harm from. And we're just looking at recreation. I was in Ohio when I did my work with the USGS, and we were Lake Erie as I was leaving to go to England for 10 years. That lake had 17 miles of cyano bloom that you had to shut down the water for all of Toledo, all of Cleveland. They had to use bottled water for a long time. It shut down all of the fishing. It was just horrible. And then that doesn't even mention what we don't know about the aerosols. Because if you get that much, it's going into the air as well. So anyway, so that's hepatotoxin, that's microcystis. The next one down is neurotoxin. That's a nerve toxin. That's the one I always mentioned, that antitoxins. So some of the delicosperm we have here may have an antitoxin, and I'm very interested in finding out more because we did a lot of antitoxins, a little pilot study last year, and we got a lot of non-detects. We don't know whether that was because of the sunlight or the biomass or what, or some don't have the genes to produce it. So I have a colleague that was just here, Barry Rosen from Florida. He has 150 vials. He takes them and runs the DNA to see if they produce the toxin or not, or which, and also down at Woods Hole, there's a professor, his name's Neil, he's Indian, and he's put in a proposal to look at DNA as well. So I hope he gets funded. It would be funded through Sea Grant, through Hui Sea Grant. So fingers crossed he gets funded because he'll do it for a Shumet pond. But dermatologist, that's a skin toxin. That's going to give you a rash. So that one, don't know. Ligbia, you see that on the right in the box, Ligbia. Those are the ones that are on the bottom. So there's the oscillatoria and the Ligbias are filaments that are on the rocks. Like if you walk on a rock in the pond, then it's slippery. That's those. And then the BMA, I don't know so much about, so we'll just go on. They don't have a lot of records of that here. Next. So what we did since 2017, we just did 5 ponds. Each year, there have been more people interested in us monitoring the ponds and more towns that are paying us to $120 per sample to evaluate. So that includes, we've got the field samples, we get the microscopy, then we go and do the fluorometry, which is telling you how much pigment is there. That's an important thing. So we've talked about chlorophyll A. Liz talked about chlorophyll A, but the blue-green algae is the old name for them. They're all algae, they're photosynthetic, but they're cyanobacteria. Anyway, they have a special pigment called phycocyanin, and we use that to get a handle on the biomass of how much cyanobacteria is in the water as opposed to the diatoms and the dinoflagellates and the green algae and all those other things. So after years, if we had a high biomass, then we would send it starting in 22 over to the Barnstable lab if it was microcystis to see how much toxin was there. Eventually, we had enough data to say, oh, well, if you have this much biomass, there's a relationship with the biomass and the toxin, therefore. And one time we got for a biomass of 100, there was 8 parts per billion. So that's why that number is there. So there's 2 ways that we could consider it a potential for concern. One is because you see the scums, and 2 is because you have a biomass. The third part about the toxins, Barnstable County Lab has generously did years of work for us. Now we pay for them, but they don't do it instantly. So we send them a bottle, they have it, they have to do a lot all at once. So this year we bought a screening tool from Abraxas so that on the same day, if we had a scum and we had enough toxin, we can make a screening. And then if it looks like it's high, then we'll send it over to the Barnstable County Lab, and then they can certify how high it is because they're going to use a different method instead of just a screening method. Long story short, this is a updated risk table, and we're using it now. And so before, if there was any scum at all, anything at all, we'd have to make it a potential for concern, and it would be yellow on the map. But a lot of times we didn't have much biomass. And so then the health agents were really frustrated because it doesn't look like it's that bad. So we upped it. We said, okay, if you have a scum and it's less than 100, you can still be acceptable because nothing we've found is going to say that that's going to be that harmful. On the other hand, we used to get ponds that were very green and they didn't have a scum. without the scum. We had nothing in our wrist here that would tell us that it should be a potential for concern. We didn't have any basis. We had to send our pictures to the Massachusetts Department of Health, and unless they said it was a significant scum, we had no basis. And Cliff Pond was one of those where you had huge biomass. Apparently, in terms of, Liz, in terms of your comment about or considering it being pristine, there was a Boy Scout camp there once, and the Boy Scout camp had a laundry. And that's down in the sediments of Cliff Pond is they still have the phosphorus and things that were left over from the laundry, which is what's kicking in, some of these blooms. I think the only thing right now, I'm going to say in advance, we have 5 ponds we got cyano alerts out because they hit on having a potential for concern. It doesn't mean that you can't go in the water. It just is a potential for concern. And therefore, if it's yellow and there's a potential for concern, use your judgment. If your ticks are a problem for you, use your judgment. If your poison ivy is a problem for you, use your judgment. That's what APC is doing. We're just trying to provide information so that people know if there's a possible problem out there. And the last one, which is red, is that if the toxin level gets measured at 8 parts per billion for microcystin, which is the only one that we have any recommendations for, the map will automatically go red. All the towns are on board with that. And if they have a bloom in a town where they're concerned, and they say, we're going to close the pond, all they have to do is tell us, and we will make it red. And then everybody will know. The people that are coming, in terms of economics, that are coming from afar, they can look at the map and decide where they're going to go. If it's red, that's probably not the pond they want to go to for their kids to go swimming. Next. These are the ponds. We've already talked about some of them. And I'm just showing of all of the Eastham ponds that we've monitored for cyanobacteria since 2001, right? I can't even read my own slide. For 4 years. This is, the blue means it's been acceptable the whole time. The only pond in Eastham that had any kind of bloom in the last couple of years was Great Pond, and that's the yellow, and that's when it happened and in the year that it happened. So overall, since I am new to all this on Cape Cod, I didn't start working at the APCC till 2023, thankfully to the commission for hiring me to head of the other, what'd you call them, Super 50? Yeah, anyway, so I worked with Tim Pasikarnis at the commission. If you want to know more about how we did it, you already explained it, Heather, but our task was to come up with which 50. So I'm part of the blame, if you want to blame, because some people didn't like it that their ponds weren't chosen, but we did our best. And so they're to represent Cape Cod, those 50 ponds, and we'd like to expand it and look at more ponds in terms of treatments, but we'll see how that goes. So those were the years. And next, these are the ponds where they are, but you're in Eastham, so you probably know that. But those little red dots are the locations. And we've got 4 years of data on all those ponds for cyano. So in terms of trends, what do we know about the water quality that goes with this, right? All we do is look at the protective side. We didn't have the money to go out and collect bottles of water. We have temperature and we have a turbidity or, some of the basic temperature, things like that. So along came the Freshwater Initiative, and we now, for all those 50 ponds, we're also collecting the cyanobacteria. So we can have nutrients, et cetera, all this information to go with it. Next, we're almost done here. This is the map that if you want to look at what's what on the ponds, this was yesterday's map with the blue of the acceptable, and we can go, you go to apcc.org. I think the next slide is probably my last slide. And this is a close-up today that shows the Brewster and the Orleans ponds. There's 5 that have already got blooms. We're in May, folks. So I think this year may not be so great for the cyanobacteria. I was so fortunate in 2023 when I came on board, I said, well, I think if we have a cold, wet summer, we may not have so many blooms. And I was like, fortunately for me, because I was learning how do you do that many ponds in 2 weeks? Yikes. And if we get a pond, like all those yellow ponds, that the potential for concerns, we go to weekly sampling. We're not doing those bi-weekly anymore. We have to go back next week to see if it's gone away. So we end up having to do more sampling. And I guess that was the last one. If you go back for a second, I want to point out, when you click on a pond, not that one, just that last one there. So when you get to this website and you see, if you zoom into the ponds you're interested in, then you get to the pond, you click on it, and it opens up the box. What's interesting here, see, that's little schoolhouse pond. And way down at the bottom, we are putting on the website the toxin from our screening. So what the screening for schoolhouse this week was 5 parts per billion. So that's pretty high, because the biomass was only 175. It was not huge. And Schoolhouse Pond in Brewster last fall had a very high, I mean, it was 20s, it was 50s, parts per billion. It was super high, and it's a little pond. So, but we'll put in the screening because that's something that we've done. The public has a clue that there is some microcystin out there. We can't do it for anything else. All we can do it for is microcystin, even though we're going to be doing some antitoxin work. We don't know what to do with that data. So it's not going on the website. It'll go to the health agents. They can see it. And anytime, like it was over 5, so we sent the bottle over to the Barnstable County, and they will do the certified, and we'll get that data when we get it, and we'll send it to the health agent. And if you have any other questions, I could talk, but it's already, oh my gosh, is it already 5 of? No, quarter of. Oh. Okay, well, thanks,
Julie.
You're welcome.
So I think we can stop sharing and answer some questions if folks have questions. Anyone?
Chat as well.
Yeah, I'm looking at the chat. I can see we have some participants. It looks like Karen has a question. Karen?
Hi, so I'm going back to the Eastham Pond and looking at Little Depot Pond. What do you think the major factors are in the pond water quality there? And I'm going to say that anecdotally, we noticed that once Orleans moved the power lines off Crystal Lake, we got a huge influx of cormorants that have shown up on our wires ever since. And I know there's a lot of storm runoff into that pond, but what do you think the major factors are there?
That's a good question. Little Depot is a small pond, so any influx, again, we talked about the size matters for how ponds react. I know it's had and Jane, you may have to jump in and help me out here, because it's been a while since I've been out sampling on the ponds, but that one has some type of surface water connection too. Is that correct?
No, there's no it's isolated.
Oh, okay. All right. So it's not connected to
Connected to
Depot or,
No.
yeah.
No.
So sorry, I don't have any good answer for you, but it does seem to be the single pond that the water quality is declining.
I'm on the Conservation Commission, and 5 years ago we talked to Eversource about moving the power lines, but they said, oh, it'll cost the town $500,000 to do it. So we kind of put that aside. But I guess it's worth keeping an eye on. And
Yes.
I assume when we do complete streets and that project, we'll look at stormwater issues as well. So
Yeah.
Looking at Depot Pond, it's interesting that's one of the ponds that was highlighted. DMF did a lot of work on the herring run there, and the town, of course, put a new culvert in at Great Pond, so that should be a much clearer passage up to there, which I think might affect the water quality in a positive kind of way.
Yes, it could, reconnecting, and then just it kind of helps improve the the water, you have less risk of stagnant water as well with that improved flow management.
Thank you.
Sure.
Liz, do ponds ever come off the 303D list? Have you ever seen ponds come off the list once they're on?
They do. 303D list means that you need to have a TMDL allocation. So you have to do some study of what are the sources of pollutant that's contributing to the impairment. And then that has to get, approved by the state and the EPA. And then once that is in place and you have a mitigation plan or an action plan, in theory, it comes off the list. Have I ever seen one? Yeah, but Onondaga Lake in upstate New York was on the 303D list and was eventually delisted, but it was a decades-long process. So,
Okay,
yeah.
thank you. Any other questions? Yep, up to the mic, please.
Is there any discussion of treating herring pond with alum? Right now?
Right now,
Well, within the foreseeable future.
Well, as Liz showed the graphs, that the alum is doing what it's intended to do, which is binding the phosphorus to a high degree. We know that it's a Band-Aid. It's not a permanent fix. So that's why we continue to do the monitoring, and we're committed this summer to do even more monitoring than done in the past, just spring and fall. So we're keeping our eye on it. In terms of concerns, we will continue to evaluate the information as we continue to see the data. So I guess it's a consideration because it's certainly a huge investment for the town. We've already done it once. It's proven to be a success story. So we want to continue to see that water, maintain good water quality for recreation and so forth. So we're continuing to look at it.
Okay.
There's no commitment today, I can't tell you that, to redoing the alum treatment. There would be a lot of back work that would need to be done before that would happen. And that's why we continue to work with Liz so that we collect the data, we have these conversations, and, it's an ongoing discussion because these are living systems that are subject to so many environmental factors, some historical factors. In some cases, it's farming that caused that sink of the nutrient load. And, it's not getting flushed out, it's retained. So in the case of herring pond, that phosphorus is bound by the alum, and we know it's not a permanent fix, but we'll continue to monitor as long as it continues to do its job. And it is showing right now that it is working. I understand that what you're saying, that algal growth is seen on the shoreline and so forth, but it's a very complex problem. We're doing our best. So continue to bring that information forward to the health department, because all the information we get, the eyes from the community, really helps to do this analysis on an ongoing basis.
Well, that's good. It's interesting you mentioned that the alum has kept and bound the phosphorus.
Yes.
Although Liz didn't talk about phosphorus, she talked about chlorophyll, or was it a different measurement that she related? She did not talk about phosphorus.
She was showing the effectiveness of two parameters used to evaluate water quality.
That's true.
And
Yeah.
the key nutrient in ponds that causes algal growth is phosphorus.
Phosphorus.
Whereas in salt water, it's nitrogen. However, it's not just one and B1. It's a combination of nitrogen and phosphorus, but that's the key nutrient that we're trying to remediate. That, it's trying to be, if we can bind that up so that it doesn't get back into the water column and recirculate, that improves the water quality.
We do have the phosphorus data on the updated fact sheet, so that is available too on the website.
Oh, good.
Yeah.
All right. I'll take a look. Thank you.
Welcome.
By the way, congratulations. I didn't know Kate was doing all this.
Yeah.
This is new. I mean, I've been around for 50 years. And I'm glad you're doing the research. Appreciate it.
Glad to help.
Any other questions from the audience? Anyone online? No, and just so that everyone is aware, we are working on our website. We do have sampling results available. We have a link to the Cape Cod Commission Water Quality Portal. We have a link to the APCC Cyano map and a link to the Barnstable County beach sampling data. And the reports, we have the pond report from Liz that goes along with her presentation. So that was updated November 2024. We have the updated fact sheets for each of the ponds, which I think you're interested in. We have the cyanobacteria report from APCC for this past year, and we have the photo guide. So we're reworking the location of things so that it makes sense when people go on there. It's all on there. It's going to be pretty difficult to find. So if you want to find it today or tomorrow, reach out by email and I can just send you a direct link. But probably next week we'll have it in a more cohesive arrangement. Thank you, Julie. Thank you, Liz. Thank you, Heather. Thank you,
job.
Jane. Thank you, Susie.
Thank you
Okay.
for coming and updating us on this. Appreciate that.
Of course.